Alrighty, in this video we're going to try and look at absolute value functions and their graphs and see what happens with them. Now, to start, what we're going to do is we're going to take a look at the absolute value of y equals the absolute value of x. Now, to graph this, think about this. Just plug in points. If I plug in 1, what's the absolute value of 1? Well, it's 1. Plug in 2, the absolute value of 2 is 2. The absolute value of 3 is 3. So on and so forth. The right side continues on this pattern. It looks like a line. However, let's take a look at negative 1. The absolute value of negative 1 is positive 1. Ooh. The absolute value of 0, by the way, is 0. The absolute value of negative 2 is positive 2. The absolute value of negative 3 is positive 3. The absolute value of negative 4 is positive 4. So if we take a look at this, what it does is it actually makes a straight line in that direction and a straight line in that direction. It actually makes a V shape. Okay. Absolute value graphs are V-shaped normally, at least when the insides are linear or basic linear functions. So if I take a look at this one, it's the absolute value of x plus 1. Well, if we plug in 0, I get 1. Plug in 1, I get 1 plus 1 is 2. The absolute value of 2 is 2. So it kind of goes on that. If I plug in negative 1, negative 1 plus 1 is 0. The absolute value of 0 is 0. Plug in negative 2. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. Ooh. Well, negative 3 plus 1 is negative 2 and then positive 2. Ooh. So it still makes that V-shaped. Okay. This time, it's a little off. Okay. My line isn't very good here because I don't know why. This tablet doesn't like me. Right? So if you look, it's almost the same graph, but it's kind of just moved. If we try this one, if you plug 0 in for this one, the value of 0 is 0, then you subtract 2 because of the order of operation, you get minus 2. Plug in 1, the absolute value of 1 is 1 minus 2 is negative 1. Yeah, we got a negative. That's okay. Plug in 2, the absolute value of 2 is 2, minus 2 is that. Well, let's try the negatives. Well, the negatives just become positive, so the absolute value of negative 1 is positive 1, minus 2 is minus 1. So on. And there we go, we have our third graph. Okay, and I'm trying to be as exact as possible and hit the lattice points. And you can see the shape is the same. It's supposed to be straight line. Ugh. I got a tool that fixes this. Maybe I should just pull that out. Something more like that. There we go. A V, there we go. So they look the same, however they're just in different places. If we take a look at some of the things. If we take a look at the B on the inside, if it's on the inside, what it does, it shifts the graph left and right. The inside moves the left and right. If it's like x plus 3 in the absolute value, it shifts it actually to the left, which is a little backwards. We're used to it being left or right is positive, but in this case it actually goes the opposite direction. If b is negative, so it's x minus 3, well, just do that, minus 3 in the absolute, that's a plus. And so value of x minus 3. Well, if we do that one, it's just to the right. Interesting, okay? They're backwards for once, so that's okay. Try your shifts out. If it's on the outside, it's going to shift our graph up or down. Now this one does not follow that rule of opposites. If it's greater than 0, it shifts the graph up. So think of the absolute value of x plus 3. And then if I have it on if it's less than 0, aka it's negative, it moves it down. So the absolute value of x minus 3. Look at the difference between how it's on the inside and outside. And that's key for our shifts, especially when we do more of them. All right? Can you state the function, state the domain, and the range, okay? So if we look, this is just an absolute value graph shifted 1 unit to the left. Well, the left and right, it's going to be 1, and I made it positive because it's left. Okay? The domain is, well, what can you plug into the absolute value function? Well, you can plug in anything. It's actually the reals, or negative infinity to infinity. And the range is, well, what's the lowest it goes? Well, it goes to 0, includes 0, and the highest it goes is infinity. Over here, it's an absolute value graph, but if we look, the v has been moved 2 down. Well, it's the absolute value of x minus 2 because the minus comes from the up and down, and it's on the outside. The range, again, is the reals. Okay, you can go left and right as far as you want. There's always something to put in. But the domain, the domain is the reals, but the range, on the other hand, what's the lowest it goes? It goes to -2. It goes as high as infinity, and you can get to -2. Right, this is a little different one. Okay, let's just keep going like that. Well, I have it all positive. It looks like an absolute value graph. It doesn't look shifted. Well, if I look at it, how do I make them all negative? Well, how do you make something negative? You put a negative on it. Well, this one is y equals the negative absolute value of x. The domain is still the reals. You can still plug in anything to this. But the range now is -infinity to 0. It goes low and goes all the way to 0. It's always less than 0. Okay. Notice how that did something to the graph. What did it do? It flipped it. It flipped it over the x-axis. And that's important to take a look at. Okay. So, the last shift we have to take a look at is if we put a number in front of a. Okay. In this case, this is our absolute value of x function. Y equals that. Notice how it's 1, it's 2, you get 2 out, plug 3 in, 3 out. If the graph gets wider, okay, it's not the same as the graph getting skinnier. It makes a big difference. Okay? I need to take the absolute value, and I've got to do something to it. I've got to put a number in front of it, or at least the x, so that when I plug in 1, I get 2, I plug in 2, I get 4. Well, doesn't that make sense to double it? It's a 2x. Notice how it gets thinner, right? Which is important to look at. It got pushed inward. However, this one, if I plug in 1, I get like, well, if I plug in 2, I get 1. If I plug in 4, I get 2. It's kind of halving it. Well, that's going to be a compression factor, okay? If you have a 2, the bigger the number, the skinnier the graph gets. If it's between between 0 and 1, it's going to kind of like the graph got sat on. So be careful of the compression factors that we look at. This is a horizontal and a vertical, or horizontal stretch if you want to look at it. We're going to look more at the vertical stretches. Okay. And the rule is as a gets greater than 1, the graph gets skinnier or pushed inward. Think of it that way. However, if it's between 0 and 1, it gets fatter, as I say. And it's actually getting pulled outward, stretched outward. Okay? Those are all the shifts we do have with these. Okay, they're Dr. Wiley. Okay? And think of it this way. Inside, it goes left, right, or it's opposite. OPP. If it's outside, it's up and down. If there's a number in front of our x, the bigger the number, the skinnier the graph is. So, a number in front, the bigger equals thinner. Think of it like it's going to the gym more times, so it makes it thinner. And then the smaller, aka between 0 and 1, it is fatter. Somebody sat on it. Okay, so those are the shifts with the absolute value graph. And we're going to see those shifts in transformation are true for all of our graphs. Okay, so keep working on it, and we'll see you later.